Okay, so wanna know something funny? Remember how I was complaining about the audio for like a couple of weeks or whatever? It turns out that I was kind of an idiot and accidentally set one of the noise suppression filters on my mic to 0 decibels reduction, which means that it was running and probably detecting the noise or however it works, but it just wasn't doing anything to it. It was just like acknowledging it. Yep, it's there. So the audio is not by any means good, but it's better. I mean, you can't hear as well the very obvious high-pitched wear of the fans on my computer, right? Which is really all I wanted. I don't need like great quality. I just need it to not be so obvious, right? Anyway, here we are, making game again. Um, yeah. Okay, yeah. I'm trying to do this. Um, yeah. Let's continue making this game, I suppose. Um. Okay, first of all, let's check on what we have, right? What we have so far is movement, platformer movement along a spline, along a path that can sort of follow this path, right? And that's about it, really. There was a bug that we wanted to fix. Let me see if I can recreate it. Yeah, I don't know if you can see it, like, shaking. It's not supposed to do that. But there's also, like, a bigger issue in the collisions in that, like, if I twist this a little bit to be like this, it will then, my little player, just sort of be unable to jump up and get caught in it for some reason. Mysterious reason that we do not understand yet. Right? Last time I was doing this, I theorized that maybe a way to fix it would be to make sure that the movement handler, that the player is snapped to the path, or rather, that the snapping to the path happens before the movement is calculated. So then we perform movement on that rather than, right? We perform movement as if a path has been snapped to, and then that movement is the one that we call move and slide. So essentially, this has to happen before this, but that means that there's a bunch of stuff that doesn't quite work, does it? Because right now, Path Snapper is built sort of with the assumption that it is going to snap the player. And actually, now I don't want it to do that. I want it to snap a position to the path. So I want it to be given a position, give me the position, but snapped, right? And that is a bit more difficult, but we will see. First of all, is there a function that can help me here? Is there a way that I can, given a path follow 3D, or not even a path follow, just given a path 3D, is there a way that I can get the point that is closer to a certain point? No. No, there isn't. Oh, but there is a curve. Can I do that with a curve? Get closest point. Ooh. Ah. Okay, so I can get the point that is closest to a point. So that is good. That is good. That means that I can actually do things. Okay. So what I want to do here is yeah, this should work a bit differently. Snap movement should not be called snap movement. It should be, let's actually make it as a function because I'm anticipating that I'm going to need to rewrite a whole bunch of this. Get, yeah, snap position to path, right? It's going to be position to snap, and we're going to make sure that it is global. It has to be a global position to snap, right? And this is going to be a vector 3. We don't care about the headings and pointings. We don't care about any of that yet. And this is going to return a position of its own. Going to return a vector 3, right? So then, the way that this should work, it should be very simple. It should be taking this global position and it should be returning the closest point to that path. So path, we're going to take the path snap point. Do we need the path snap point, actually? Because I'm getting the feel that we don't, actually. Let's make this work a bit differently. This is given by the player node, right? So the player node, rather than the path follow, it's going to give you just a path node, right? A path 3D. And then the path, yeah, the movement handler path going to receive this path. This is like a big change in the architecture. I don't like it. And then this is going to, yeah, this is going to, rather than a path snapper, no, rather than a path follow, it's going to be a path 3D, and this is going to be just a path. It's going to be called path. And then this is going to receive the path, and then this is going to receive the path, which is going to be a type path 3D, right? So we're receiving a path rather than the follow point. We don't actually care about the follow point because we're going to be using the path directly. So then, really all that we need to do is to take this global position, and make it local. Oh, shit. Wasn't there a way to make a global position local to a node? Local? To local. Yes, okay. Yeah, okay. So now we convert it to a local position, right? Okay, so upon being converted to a local position, what should actually happen? We should get the point that is closer, right? So path curve, we take the curve and we say get closest point to this, right? So variable local position to snap equals this, and when we take this local position, make it into this, and then yeah, and then we take this and make it a global to global. Yeah, we take that and we make it a global. Okay? So we make it local so that we can use this to get the closest point, and then we get that point and we make it a global. And then we have it a global, we can return it. So return. Yeah. Variable snapped position equals that, and then return it. Return snapped position. Right? That with the idea. So then we are not going to actually need these, are we? Not yet, anyway. Let's just do it like this. Yeah, I'm just gonna... Yeah, like this actually. Right? Yeah. So essentially, what I have here is a function that, given a position, will let me get the position that is closest to the path that has been given. So then the movement handler can do some shit, I guess. Where is it? Yeah, just delete everything. Oh fuck, did I... Oh god, I think I didn't commit my changes last time. Oh shit, oh fuck. Oh no, I may have just fucked the repo. Oh no. Last... Oh fuck, I didn't do it. Okay, so we better hope that this works then, because I just deleted a bunch of code. God. Okay, so where is the stuff? Yeah, okay, so this is the part that we are having trouble with. So yeah, having calculated all the movement, then we're gonna talk to the path snapper. We're gonna tell it, hey, I have this position that I want to end up in. Oh shit, how do I calculate that position actually? I'm gonna have to calculate that from the velocity, aren't I? Is there a way to do that automatically from character controller? Like to get the position that move and slide would end me on without actually moving and sliding? Yeah, but this is the last movement. Yeah, that's not what I want. Not really. This is an issue then, because I'm not sure how to get this. Like, Modifies velocity of a slight collision occurred to get the latest collision. For more detailed information about collisions, you get that. When the body touches a moving platform, the platform's velocity is automatically added to the body's motion. Motion occurs due to the platform's motion will always be first. It's true if the body collided, otherwise false. The issue is that I have the velocity, but I need to calculate where it would end up with that velocity. Then pass that to the path snapper so that the path snapper can give me a position, and then I convert that position to a velocity. So I'm gonna need to manage a way to get positions into velocities, or rather to turn velocities into positions. If it is meters per second, then I'm gonna need the delta. Yeah, I'm gonna need the delta. Okay, so here's what we're gonna do. We're gonna do two functions. Function velocity to position. It's gonna receive vector 3, that is the velocity. And it's going to return a vector 3, that is the position. And then the inverse. Position to velocity. It's gonna receive the position, and it's going to return the velocity needed to reach that position in the next frame, right? Which means that these are going to need the delta. Right? So then, we first of all are going to need to do that. So we have the velocities, we have them here, so then we're going to need to get those. So var end position without snapping, pre-snap is going to be velocity to position of player body point velocity, right? And the delta. Right? So having that, we can use that position and give it to the path snapper. So we take the path snapper and we tell it to snap position to path, and the position that we want is the end position pre-snap. Actually, that without this extra, the end position pre-snap, and that is going to give us a real end position, right? And then we're going to take this real end position and convert it back to a velocity. Which we're going to assign to the player body. So player body point velocity is going to be equal to position to velocity of that real end position, and taking into account the delta, the delta between frames. And then we can move and slide, and then this can just die. So now we need to figure out these two functions, right? So how do I turn a velocity into a position? Well, the issue is that I actually need the starting position as well as the velocity, don't I? But that's fine, because that will always be the player body in this case, right? So we start from the player body. Oh yeah, one thing is that this position needs to be global, doesn't it? end position. Let's put that in the name so that I don't forget later. Global end position before the snap. So then we take the player body's global position. We start from there, right? So to that, we're going to add the velocity times the delta. Times the delta. Velocity to global position, just so that I remember. To global position. And we want to return that. I think that's the way it should work. And for the velocity, from the position to the velocity, it should be sort of the opposite. So global position to velocity. So then, yeah, it should be sort of the opposite. So we have a global position and we want to calculate the velocity that we need to add to the player before, so that it ends up exactly at that position, right? So then also this should be position, not position. So how do we do that? This should be math, actually. So, like, yeah, let's do it math-wise. Let's do it like as if it were an equation. So we have the global pos, and we are adding the velocity, and we're timesing the delta, and that is equal to our oh, yeah, we have our start position, and that is equal to our end position. These are both global. And now, yeah, and that turns my velocity, my delta, and my start position into the end position. Now what I have is the end position, the position of the delta, and I want to turn that into the velocity. So I'm trying to solve for velocity. So first we subtract the start position. Start position. And then we divide all of this by the delta. Divided by the delta, and that should give us the velocity, right? So what we want is, we want to return it. We want the player body's global position is the start position, so it should be the end position. So we want the position, subtract, that is the position that we're going to get. Subtract the player body's start position, and that gives us that displacement, so how much the player has to move, and then we divide that by delta. By delta, then that gives us the velocity that will put the player at that position. Right? That, mathematically sound, but I'm not sure that it's actually correct. The other thing is that the path snapper has a bunch of... Well, actually it doesn't. I just deleted it. Does that work? You're saying the path is a null value. Why is path a null value? If path equals null, return. If I print the path, is it null every frame? Yes. Okay, so the path is not being correctly added. So what does the player do? The player tells the movement handler, hey, this is... Oh, yeah, it's because the test scene... I didn't assign in the test scene. Yeah, so the path is actually this one. And we don't actually need the path follow, turns out. Yeah, so now it has a path. Okay, something weird's going on and I can't really see it, so let's move the camera. Where's the camera? Mom, get the camera! Yeah, let's put it here so that I can see what's going on. Movement seems to not really be following physics. Oh, I know what's going on. Yeah, the path snapper is returning a vector 3, but it actually shouldn't be returning the... Yeah, it's actually snapping it to the point in the grid, but I just remembered that I have to ignore the Y position. So I have to do that. So, yeah. Also, stop printing path. And, okay. So what I want is this local position to snap, and this snapped position... Yeah, and then we take this snapped position, we take the Y, and we say the Y has to be equal to the global position to snap Y. So we retain the original Y coordinate. That makes it that it falls. Okay, so that does work, kind of. There is an issue in that it stops advancing, right? Not only that, it seems to advance slower the more angled against the horizontal axis this thing is. And I think that that's because it's not rotating, right? So the player is trying to move this way and finds no closer point along that path. So it needs to rotate this thing along the path, right? We need to figure that out. Actually, I think that we do need the path follow. Don't we? Do we actually? Is there a way to get the angle of a certain point of the path? Curve change, right. Having a point on the curve. Get point in, get point out, get point position, get point tilt. Remove point sample baked. Get point tilt. Right, but these are going to be for points, not for just a point, right? Get, like I want get closest point. Closest point on baked segments in curves local space 2 point. 2 point must be in curves local. Yeah, so having that, can I get the tilt of that, like the rotation of that point along the y-axis? Add point, clear points, get baked blank, get baked points, baked tilts, get baked up vectors, closest offset, closest point. Closest offset? Oh yeah, that's not really helping me. Point position, point tilt. Sample. The position between the vertex of the ID and the vertex, the next one. Oh. Yep, okay. Not what I want. Samples. Set point in, out, position, and tilt. Deselect. Yeah, I think we're gonna need a point follow then. Path follow 3D. And this one's going to need to be aware of it, so... the path that it's following and the follower that is assigned to it. So player tilt. Yeah, the path follow that corresponds to the player, right? And so path or var path follow, so the, and this is going to be of type path follow 3D. And then as soon as you begin, you're going to also give this to the movement handler, right? And so the movement handler is going to take that path follow, similarly, yeah, just like this. So var path follow 3D given by player node, and when the value is set, you're going to not hold on to it. You don't care what it is. Actually you kinda do, don't you? Yeah, so how do I do this then? Because the path snapper should be in charge of this kind of thing, right? So we set the value and we tell the path snapper, hey, the path follower that corresponds to the player, it's right there. This value, right? Path follow, yeah, it's going to be equal to that value. And then we are going to add something to this, and this is going to be the variable path follow that is going to be of type path follow 3D. And then what do you do? What do you do with that, right? Well, when you get a snapped position, you should also rotate the player. Well, actually, no, you shouldn't rotate the player. You don't need to know the player. That's sort of the meme that I'm going with here. I don't want you to have to know the player. So the movement handler is the one that's in charge of rotating the player. So then it is going to request you for that rotation. Right? So, yeah. Player rotation should be a float because it's just rotation along the y-axis. Player y rotation is going to be the float. Last y rotation, yeah. And whenever you return a snapped position, you're also going to calculate that rotation. So get rotation, let's just make it a function. Get rotation, I'm gonna say last y rotation is going to be equal to whatever we get out of get rotation of that position. So snapped position. Actually, let's just use the snap position before we nullify the y so that we know that it's going to be a point along the path, right? And then function get rotation is going to be equal to, we're going to start from position, so position on curve is going to be a vector 3, and it is a global, I think. Yeah, global position on curve. And this one is going to return a float, just a float. So then, you're going to take path follow. You're going to tell it, hey, shit, actually, how do I do this? So I have a position that I know belongs to the curve, so if I just move you, returns the coordinates of a point within it, given a distance from the first vertex. It is useful for making other nodes follow a path without coding the movement pattern. Could I just change the position of this? Like, change your global position to this, and then obtain your progress? Okay, actually print it, do that, print it. Before we do anything, just print it. And then return, I don't know, fucking 0. Just to test stuff. Yep. What? Base object of type nil. So you're saying that this is nil. This is the path snapper. So you're not receiving the path follow? So you're not receiving the path follow? Are you not? Is the player not giving you the path follow? Oh yeah, of course it's not because I haven't assigned it yet. Again, the same issue again. I keep forgetting to do that. Okay, now it should be. Yep. It's of course returning 0 every time. That's fine. Right, so this is an issue because this is what it's printing here is the value of progress. And that means that moving your position to that position has not altered the progress. Unbaked segments. Can I get the progress from this? Maybe not from the curve, but can I from the path? Okay, so the issue is that what I want is I have a position that I know is on the curve, and I want to know what rotation is pointing forwards along the curve. That is the actual issue. Returns a point within the curve at position offset. Get offset. Sample. The position between the vertex idx and the vertex idx plus 1, where 2 controls the point in the first vertex. Also, if the point is in the first vertex, the last, or somewhere in between. idx is out of bounds. Returns the point within the curve at position offset. Where offset measured as a distance in 3D units along the curve. The points could the closest offset to 2 point. Sample baked. I think that's what I want. I'm not sure I'm understanding this right, but I think what I want is to get the closest offset. What was it? Get closest offset. Yeah, I think that's what I want. Let's try for that. So Yeah, I get the... In order to get the rotation, I want to get the closest offset. Yeah, the progress of this has to be equal to the path, get closest, get... Not the path, the path, the curve on that path, get closest offset, and we're making sure that this is the global position, not local, global. Good thing I called it that. And that's gonna give us the amount of progress. If that works, then I can take the... Well, that's giving me a number. Is that the number I want? Let's say 355.196. Doesn't seem to be 343. Because this is 340. And then this is 350. Okay, take this and add like a cube to it so that I can see it. Cube. CSG, just a box. Make it a bit bigger. Yeah, and it has no collision, so... Yeah, let's remove this just so that I can see stuff better. Yeah, it's not even close to the position that I want. But it does seem to be something. I may be on the right track and just doing it wrong. And getting the closest offset to that global position, except no. No, it shouldn't be the global position, actually. It should be the local position. And then I should give you snapped position. You get the position as local to curve. No, I'm silly. That I shouldn't have done that. Yeah, it's this, the local position that I'm going to snap. You snap it. Snapped position as local to curve. And that is this. And then snap position as global is this. And so we take this, this, this. And so what I want is to use the snap position as local to the curve here. And from that, get the rotation. So I get the position on the curve as local to the curve, get the closest offset, then turn that into the progress of the path follow, and then tell me what that is. But actually I don't need, because I can see it. Okay, so now I see, and the cube is actually following where it should be following, which is what I want. Okay, good. This is working. Okay, so then instead of printing it and returning 0, 0, I want you to return the path follows rotation y component. And just so that I can see it, actually, is it y that I'm thinking of? I think it is, but let's be sure. Let's see. If I rotate you along the y-axis, yeah, it is the y component. Okay. So then, actually, let's make sure that. Yep, no, it is the y component that I'm looking for. Okay, so then what's gonna, so then the path snapper, I'm returning this y position, and I'm saving it as last y rotation. Right, I'm saving it. I'm not doing anything with it yet because it is the movement handler that handles the rotations. So then, yeah. You do the move and slide. Actually, let's do it in the snap. No, let's do the move and slide first. You do the move and slide, and then you apply the rotation. So player body point rotation point y is going to be equal to the path snappers saved, no, last y rotation. Almost. The correct rotation is that plus 90 degrees. So, 90. Actually, plus 90. Rotation degrees by plus 90. Last y rotation degrees. Honestly, I could calculate it with radians, but that's just a huge pain in the ass. Degrees. Last y rotation degrees. Hell yeah. Okay, so really what I've done here is re-implemented the movement, but it should have made it so that that bug doesn't happen because the movement is being calculated before, or rather after snapping to the curve rather than before. Well, actually I shouldn't have put it on top of the player. That's not a great idea. So now, what happens if you move into a wall? You just seem to collide normally. Okay. What happens if you move into the wall from sort of the other side, right? So like if I move this here, rotate it so that I can see things. What happens? The movement is absolutely flawless. Oh my god, that's so satisfying. Oh hell yeah. That's so satisfying, I'm tempted to end the stream right there. Just not keep working on it. Like honestly, you know? maybe I should do that. I mean, it's not like this. It's nothing, just being lazy. uh, okay, I am going to do that, but I should save. I should decide on what I'm going to do next time if I'm going to just end it this soon. Because honestly, that went a lot smoother than I thought it was going to be, considering how complicated of a thing I was trying to do. I was fully expecting this to be just a complete shit show, and if like it actually worked, like pretty much first try. I'm good at programming, man. I don't give myself enough credit. I'm pretty good at this stuff. I'm figuring out this sort of math-heavy position stuff. I guess I have a lot of practice. Man, I haven't even been doing this for an hour. Okay, let's decide what I'm going to do next time. I think next time, because this was all of it movement. Next time I definitely have to fix the bug. Actually, I could do that right now because there is a thing, right? You can't feel it because you can see it because you're not controlling it, but there is a bit of an issue with collision, right? Like, look at this. If I go into a wall, it takes a while for the guy to sort of react, right? Like if I'm pressing right and I'm pressing left now. If you hit into a wall, the player seems to remember its velocity when it kind of shouldn't, right? So that's a thing that needs to be fixed. Actually, I can do that right now. Let's do that right now. Yeah, sure. You know what? I was just saying that I didn't spend nearly enough time doing this, so let's actually do it right now. So this should be the movement handler. What happens when what's going on? Because I know what's going on. This is like a fairly freaking bug when you're doing movement stuff like this. That is that the player hits a wall and the wall stops the player correctly, but then when you try to move left, the player is using the previous retained velocity towards the right to calculate that velocity, and so it's coming to the conclusion, oh, I should be stopping, I should be braking here, but I'm still moving right. So it's still trying to move into the wall even though the wall has already stopped them, right? So what it should be is that when the player collides against the wall, the horizontal movement should become 0 immediately, right? I think that should be just 2 lines of fix. Actually, I think this may be just a really easy thing. Because I just realized there is a function that will do that for me. Is get last motion. Move and slide. Movement can be split into multiple motions when sliding occurs, and this method returns the last one. No, that's not the one. It's real velocity since the last call to move and slide. Yeah, so I want to do that. I want to get the real velocity and yeah. Actually, how are you dealing with horizontal velocity? Are you taking... Huh? Current horizontal speed? It's a global parameter, so... Yeah, so this is a number that's positive or negative, right? Oh, hey, kitty. I have a kitty in my lap. He wants to make himself come. Ah, you're pulling on the headphones. You're pulling on my headphones. Careful, careful, buddy. Careful. Sitting right on them. There you go. Oh, you wanna meow? You wanna let people hear your cute meow? Kitty. Nah, he only meows when he's complaining. Okay, so what do I want to do here? Yeah, current horizontal speed is a number that is positive or negative. Positive means moving towards the curve, and negative means moving against it, right? So that's what it uses this relative forward for. So then this horizontal velocity is... yeah. So what should happen when you hit a wall? When you hit a wall, that velocity should become 0. Just immediately, right? That means that after move and slide happens, you should check that horizontal velocity. Yeah, after move and slide happens, you should... yeah, after move and slide happens, what I should do is take... I think it's get real velocity. Yeah, so yeah, that's what I should do. I should get real velocity. Move and slide. Get real velocity. Get real velocity. Remove from it the y velocity because I don't care about that. Yeah, actually, okay, we're gonna create a new variable. This is for correction, right? So variable, real velocity is going to be equal to that. Then when we correct, actually, we're going to put this here, right? Then when we correct, we're going to take the vertical velocity is easy, right? So vertical velocity current horizontal speed, no, it should be current vertical speed. Current vertical speed is going to be equal to the real velocity. Hold on, velocity? Shouldn't it be speed? No, it's velocity. Okay, it'll be the real velocities y component, right? Real easy. The one that's trickier is the horizontal velocity because that depends on where we're rotated, right? Also, let me change that to-do list too so that it reflects what I'm actually doing. X, retaining velocity, collide after collision. After collision. That's what I'm actually doing. So yeah, so okay, so I really shouldn't sing along the background music just because the delay makes it probably pretty rough to listen to. Real velocity point Y. Yeah, that's the vertical speed. That's done. So the horizontal speed is the one that's gonna give me trouble. One of this is that this is only positive, so can I assume that these are always going to be the same sign? Oh, how do I get the sign of a float? I'm gonna have to ask Google that one. Which would be a lot easier if I didn't have a cat currently weighing me down. Script get the sign of a float. One second. Oh, it's just called sign. Yeah, that makes sense. Current. Okay, so this is made assuming that these are always going to be the same. Like that a collision can't just make you change the direction by itself, which I'm not sure is the case, but seems like a reasonable assumption to make. Yeah, that has fixed it. Oh god, what the hell? Excuse me? What? I have no idea what's going on. When I jump, stuff seems to move really crazy. Does that have to do with movement parameters? Do I have some parameters that I didn't edit back when I changed them to... Right? Because max horizontal speed is 80. Ground acceleration is 4. Air acceleration is lower, so it shouldn't be possible to do that. But max air... Ground breakers. Okay. So... Is this because of what I just did? Is this because of this? Right? It is. Okay, so somehow that has done that. Why would that be only when you go airborne, though? That doesn't seem to make sense to me. Also, is it every time I go airborne, or is it only after a collision? Yeah, that seems to... Because if I jump straight up, that's no problem. It's only horizontal movement after going airborne. And it seems to be when falling too. So what's going on there? Well, let's make sure that we know which of the two lines is actually causing that. It's pretty definite that it's the lower one. Yeah, for sure it's the lower one. It's making it just zoom. Okay, so why is that happening? Sine should really only return 1 or -1. So it's gonna be this, but why would that be an issue? And why would that only be an issue when airborne? Oh, is it? Current horizontal speed is not multiplied by delta at any point, is it? Not. How do I eventually use the current horizontal speed? Multiply it by the relative forward to get horizontal velocity. And then just add that to velocity. Return this length. No, the length should be... Oh, because I haven't... Right. That's why it's only a problem when airborne. Because when airborne is when velocity y is adding itself to the length. So the length is bigger because I'm also moving along the y-axis. So really what I need to do is take real velocity and remove its y. Real velocity point y equals 0, and now I have real velocity, but only along the ground, and then to get the length of that. That's what's going on. There you go. Okay. And that makes it so that I stop accelerating. Like, my accumulated velocity is not retained after colliding against the wall, so if I hit it and then start moving right, I start moving immediately. Right? So it's closer to turn around if I hit a wall than it is if I just... Hell yeah. That worked. A cat. Right. The cat is right on my arm, which makes it difficult to type. So you know what? I'm gonna say that here's where the coding ends. I'm going to think of what to do for next time. Okay, what should I work on next time? Definitely stuff interacting with the player, right? Stuff interacting with the mouth of my model does not move basically at all. I wonder why. What's the issue with that? The whole point of using a model is so that I can get to be more expressive on camera. That doesn't work if my mouth doesn't move when I speak. Hell yeah, we will do stuff for the player to interact with. I'm sure that's gonna work and not be a complete pain in the ass. Well, that felt productive, even though I didn't spend nearly as long on it. Alright, I'm gonna take a break, and after that, we're going to play Blasphemous. And hope that my computer doesn't crash. Or actually, in order to be thematic with the game, let's say that we're not gonna be hoping, we're gonna be praying. Because, get it? Because it's a game of religion and stuff. Alright, I'm leaving. Be right back.